So far, we in a C program get the data, the many data, different data using an array. In other words, we may say that we do such type of things using a static memory allocation. Now we have understood the dynamic memory allocation. So using this property, and we also know that struct, the keyword struct, is used to store different type of things. So based on these two concepts, first you may say first the keyword use of the keyword struct, and the second is the dynamic memory allocation. Okay, since a struct keyword helps us to store different things, so I take two different things. I show you one on the screen. Okay, you see the screen, and on the screen you see the keyword struct. Here will be a small letter. Okay, so this is the keyword, and this helps us to store two different things. You see, inside the curly bracket there are two different things. One is the data, and you see data, this data is an integer variable. You see the keyword int for that. And now the second thing is important. We should observe this carefully. The second thing, if you observe second thing is this thing. You see that same thing has been addressed. You see here inside the curly bracket, it is a struct node. Okay, and outside also you see the same struct node. So this whole thing will create a node containing two different things. First is will create will refer not, this will not create a node, I will say later. This only refers to two different things. First is the data and the second is the pointer. You see a star next, and you know we use this star thing, asterisk thing, for the pointer. So it indicates an address. This is for an address, and this is for the integer variable int data. Data is the variable. So obviously here the keyword struct is helping us to store two different things. First is the data and second is the pointer or an address. Now one important thing I have to say, that such declaration I have declared here, you see, such declaration does not consume any memory. So to create this thing, this should be created. Unless you create, you cannot use that. To create this thing, we use malloc function. I have already explained the use of malloc function. How can one use? In the past video, in the previous video, you can see that. For the to be clear about the malloc function, and you know malloc function creates memory block for any type of things, whether it be an integer, whether it be a character, etc. You know, an integer takes 4 bytes of memory, whether a character takes 1 byte of memory. And you should be surprised that the malloc function can create this node as well. You see the node I have typed on the screen. The malloc function can create this node as well. And to create, we first declare the name. So for that, I here type struct node star something. Suppose first we have taken this first. Now this first should be created. Here will be a small s. Any keyword does not contain the capital letter, a small letter, and here the keywords in a program looks bold, so I make it bold. Here you see the name has been declared. The name is first. Okay, now it is time to create the memory block corresponding to this name. First, the addresses are given name. You know, every person has a name, so that one can understand for whom you are talking about. So the name has been declared. Now it is time to create the memory block for this first. And you know, here we type first, and thereafter we here inside the bracket we type struct node star. If you want to create a memory block of an integer, then you should type here int star. But here I have to create a memory block for struct node, because this first, because you know this first is of struct node star type. So here will be struct node star, and thereafter we type the function malloc which helps to create such a block, and thereafter here I type the byte it takes, and as I said earlier that an integer takes 4 byte, a character takes 1 byte, so this struct node star will take the size of a struct node. So here will be size of, inside the bracket, a struct node. Okay, now the node creation is complete, and since this is a keyword, so I make it bold. This size of is also a keyword, you should keep in mind, so I make this thing bold as well. And okay, now the first, this a node named first has been created, and when it is created, then here in this program we are here to learn the algorithm, not the program or the code. So when you declare this thing in the blue background, here on the screen you see the blue background, so corresponding to this thing under the blue background, a node is created, and a node is like I show you. Node is like this type, because I said earlier that a struct can store different types of things, and here there are two types inside this. You can say that, you can check that, you can see that, you can observe that here two types are things are of two types. First is data. Here data, here the first part contains a data, and the second part is a pointer, so it points to an address, and at any address we store, here will be the address, and the at an address we store data. First address is created, and thereafter we store a data in that address. So we have two things, data part, this is called data part, this is called address part, and when we use this thing, if you use this thing two times, then there will be two things of this type. So I again repeat the same thing. If you take in the program this thing two times, I take that, I copy here, and here I paste. I have pasted the same thing, you see. Okay, then if you use this malloc function 2 times, then you have you will have this is the, this is the node. A node contains a data and an address, a data and an address. So here you have used malloc function 2 times, then there should be one more such node. So I have to draw such nodes. I have drawn, you see, and since in the both you see a struct node, so here as well there will be a data part. So the first part will contain a data. The first part contains a data, and the second part will contain will point to an address. Where is the address? Because the struct thing, we can use two different things, and here the two different things are, first is the data and the second is the pointer address. Okay, now since these two parts, you see, in these two parts, in these two nodes, there is one part retain data. So in that we can put any integer, because here the data, you see this thing, here the data is a integer variable. So accordingly we can put here an integer. Here I can put an integer. So for that I have to erase this. I go to erase this one, and okay, I erased. You can see I have erased. And integer data means you can place any integer. Suppose I place here 8, and in the same way I can place 16. And in the next part is to attach these two nodes. And how can we attach? You can understand this thing, that this part, suppose this part, you see this part is this part, suppose in this part I use a gum. Gum, gum is used to paste two things. So here I used gum, and we paste. You see, yes, I have used gum in this part, and over that green part I place this thing, in this part. Over the green part I place this part. And if you place this part, then what happens? You can imagine, very easy. I show you. If you do so, because the green part is an address, and at any address we can store an address of integer type, we can store an integer. So over the green part I paste this pink part, and when I do so, the next structure becomes the next structure will be like this. I show you. I show you. this will be the next part. If you paste, then this will be the next part. Here will be 8. I type this in red as usual. Here will be 8 and here will be 16 and here will be the last one will be an address. The last one will be this address. Okay, try to understand, very easy. If you observe carefully, then you can. And here will be address. Okay, so you can see that, you can check that this 8 and 16 has been close to each other, and when one uses this thing once more, suppose, and you should remember that both nodes are different, because in the first the data is 8, in the second you can see that, you can see here, this is the first node, you can see this is the first node, this is the first node, and in this you see the data is 8, and you see that in the second the data is 16. Both nodes are different, so the name should be different. I have used the same thing here first, here as well first, but you should keep in mind that these two names should be different. So when I pasted, I got the we got the lowest, you see this lowest thing, structure 8, 16 and address. When you go once more, suppose I again use this thing, here I copy and here I paste. So you see I have used once more this malloc function, and this is the third time. You see here is the first one in the upper part, and the malloc function you see in the middle, and this is the last one. So I have used this malloc function third time, so accordingly there will be one more node, and as usual you know that the first part contains a data, because in all with malloc function I have written a struct node, and you see at the top of this video a struct node contains a data and a pointer that points to an address. So here will be an address, okay, this will be an address, and now we have one more node, one new node here you see on the screen, whose first part is a data and the second part is an address. And in the same way, since this is a data part, you see, so here we can integer data so here we can place an integer. Suppose I place here 24. So first I have to erase this thing. This is a variable name. Now since this is a part of data, so I place 24. Now similarly we do the same, that is we here place the layers of gum. Here I use gum to cover this area with the help of gum. Here I use gum in all of its area. You can color it properly. I have done roughly to only to make you understand. And the part of the new node to be pasted there is 24. This pink part. This pink part will go over the green part. And if you do this pink part, you see the pink part, this pink part will be kept over the green part. And if you do so, then you will see a pattern. I show you that pattern. You see, I am shading this part so that this part may be visible to you and this part is pasted over the green part. And if you do so, then you will have a new structure, and I show you that structure. The structure will be like this, like this, like this, and here will be the first thing will be 8. If you paste, then the second thing will be 16, and the third will be now 24, and the fourth will be the address, obviously the address. So in every, at the end of every step there will be only one address. You see, in the previous part as well there was only one address. If you observe this, then there were two integers and an address, and here since you have taken one more step, so there is one more integer 24, and the address is the same, the number of address is 1. So in this way, if you continue, then you will have set of many integers. This continues, and if you observe this part, then you will remember that this appears to be an array. This part appears like an array, but you know, I have not used array anywhere. Without using an array, I have created a list, and this list contains 8, 16, 24, and if you move in such a way, then you can add many integers. It may go infinitely, but you know, this will take infinite time, and we don't have such amount of time, so we need to add this list, and for that at the end we will be remove this part, because you at the end this part you see, this part remains in all, but this is not an address, sorry, this is not an integer. So at the end, when I don't want no more integers, then at the end this part should be removed. This part should be removed. This part is removed by setting this address to null. Capital N, capital U, capital L, null. When it is set, the last part in the end, this, when at the end we remove this part address, and removal is done by setting this part to null. This is the algorithm of linked list. You may have understand that thing. And the first thing is to make a linked list, and this is the linked list. This part is the linked list. This part is called the linked list. This part. So we first make a linked list, and this linked list is stored in the computer, in computer's memory. This exists when you use, I have so far mentioned various steps, many steps of the algorithm of this linked list thing, and if you complete these steps, then you certainly have a linked list, but that linked list will be in the memory of the computer. And to see that linked list, one needs printf function, so that the same linked list may be seen on the screen of the computer. And that part is very easy, so I will show that thing when I write a program for this linked list. And in this video, so far discussed relate to the algorithm of linked list. So I now am happy. I now think that the viewers should have understand all these things. If you have understood these things, then obviously you will get the program very clearly. Thanks.